Life began on this planet about 3.8 billion years ago. And a question a lot of people have is, could life have formed spontaneously on its own by random chance? There's two sides to the question. On one hand is the complexity of life. Life is complex. DNA is complex. There's many facets, many things that need to be in balance for life to exist. But on the other hand, the universe is vast. There are 4 billion stars in our galaxy, and there's roughly 2 trillion galaxies in the known universe. The universe has been around for 14 billion years. So there's been lots of opportunity for life to come into existence. So what happened? Of course, we want to explore that today by using math. And so I want to start off by just talking about probability for just a minute. And we're going to explore the probability that life came into being all on its own. So when we talk about probability, a die is a very simple way to talk about it. If we roll a die and we want a particular outcome, for instance, the 4, we could roll the die once and we have a 1 in 6 probability that we will get the outcome that we're looking for, a 4. The more often we roll a die, the more likely the outcome we want is going to happen. We could, though, roll a die 20 times and not get a 4. We could roll the die once and get a 4. There's never any degree of certainty. So we can represent this graphically by showing a bar graph. The bottom bar shows the complexity of the task. In this case, there's 6 different possible outcomes. The top bar shows what happens with 1 roll of the dice. So that is a graphical display of the odds of 1 in 6. Now, if we roll 3 times, we have 3 opportunities to get a 4, and so we can represent that graphically. Here, this represents 3 chances in 6, and we would call that even chances. There's just as likely that we do get a 4 as that we don't get a 4. And so as we consider the probability that life developed all on its own, we would like a bar graph to look something like this. The complexity of life on the bottom bar and the opportunities for life to occur on the top bar, and hopefully they'll come out looking something like that, indicating that there's relatively good chance that life came into being all on its own. So let's try to populate our life complexity graph, first by looking at that first question of how complex is life? Well, actually we have a really good opportunity to talk about that, because just last year a study was published where a scientist took bacteria and they took the DNA out of the bacteria and removed all parts of the DNA of this bacteria that weren't necessary. And they stripped it right down to the bare necessity, just the parts of the DNA that were necessary for it to live, for it to grow, and for it to reproduce. And they took that DNA, inserted it back into the bacteria, and it did just that. It lived, it grew, and it reproduced. And so we know that basically the simplest life form would have something like 473 genes made up of 531,000 chemical letters. So if we think about a book, that's about a 200-page book representing that genetic code. So now obviously composing a 200-page book with just the right characters would be a very tall order. But the genetic code is only made up of 4 letters. So we're really only talking about a book made up with 4 characters. So that makes it seem not as complex. But the DNA is only one part of the complexity of life, because the DNA is like the software. The DNA has to be inserted into a cell that would be able to read the DNA and do something with it. make it active. Even the researchers in this particular study didn't create the shell. They took an existing bacteria, removed the DNA and inserted this new DNA, and that's how they made this new life form. And so we have the DNA and we have the hardware. Now, coming up with a number about how complex that would be really, really difficult. And lots of different people would have lots of different ideas about how complex life is. But I believe that everybody would agree that life is more complex than a tweet. Here is a 140 character tweet. As a matter of fact, the tweet is only made up of 4 characters, kind of like what DNA is. And so the only letters being used are the I, the A, the M, and the spacebar. And so let's imagine that we could simplify life down to just this tweet, but we need to get this exact tweet. If this exact tweet is formed, life exists. So how many different combinations of these 4 characters are there in a tweet, in 140 characters? Well, the math is really quite simple. It's simply 4 times 4 times 4, 140 times. And we represent that mathematically by this formula, 4 to the power of 140. You plug that into your calculator, and you come up with an answer, 1.94 times 10 to the 84. If we write that out, it's 194 and then 82 zeros, and there's the number. So certainly life is not less complex than that. So we can see the complexity of life has to be a big number. It's certainly going to be a bigger number than that, but let's, for the sake of argument, say that that's the complexity of life. And so we can put that into our bottom bar. That number is in the bottom bar, representing the complexity of life. And I don't think anyone would argue that life would be less complex than that. Now, what about the opportunities for life to exist? So as we said, there are 4 billion stars in our galaxy. We're a fairly representative galaxy. Some galaxies would have more, some would have less. But let's say on average, there are 4 billion stars in each galaxy. There are 2 trillion galaxies in the known universe. So if we do the math, we would put it out like this. So planets in a galaxy that could support life. This is a tough question because not every star is going to have a planet that could support life. Turns out that in order to support life, you need quite a few different things. You need a planet that is relatively stable, that has the right ingredients on the planet. It has to be in a relatively circular orbit. If it's too elliptical, the temperatures change too much. The planet has to spin at an appropriate rate. Too fast, too slow of a spin is the real problem, where one side will heat up too much. You'll have too much temperature variation. The star that it's orbiting around has to be a relatively stable star, and so all these different pieces. So people argue a great deal about what this number should be. I don't think anybody would say that the number is less than 1 planet for each, or more than 1 planet for each star. So for the sake of argument, let's just say that there is a planet circling every star that could support life. I know that number is too high, but for the sake of argument, let's just go with 4 billion. The galaxies in the known universe, the latest estimate is 2 trillion. The years in which life could form, that's a bit of a tougher question because the universe has been around for 14 billion years, but it took a while for planets to form. And even then, most planets don't exist in a stable form for all that long. So I would say for most planets, the opportunity for life to form is going to be limited to a few billion years. But for the sake of argument, let's give it 10 billion years. Certainly, there's not going to be any planet that would be stable for more than 10 billion years and allow life to form for a greater period than that. Number of seconds in each year is pretty straightforward, 365 days, 24 hours, 60 minutes, 60 seconds. Now, the real question here would be, how many opportunities per second on that planet would there be for life to form? And life would probably not form like in the vast oceans, but probably in smaller ponds and still water. And so maybe there's a trillion places like that on the planet. I think that's a fairly generous number, but let's say there's a trillion opportunities in each second for life to form. So let's do the math on that. And you come up with this number, 2.52 times 10 to the 51, and we write it out. It sort of looks like this, 252 with 49 more zeros. And that is the, really what that number represents is, imagine if you could produce 1 trillion tweets every second on every planet in the known universe for 10 billion years. That's how many tweets you could make. So let's compare that to how many tweets are possible given our previous math. And what we find, and this is a rather shocking result, is that the line representing the number of tweets we would make, if we made a trillion tweets every second on every planet in the known universe for 10 billion years, that line doesn't even register on this chart compared to the complexity of the challenge, which is to make that relatively simple tweet. In fact, when we do the math, we divide them out, what we really find is that the odds are 1 in 770 nonillion. So take 770 and add 30 zeros behind it. That's the odds that we would form that specific tweet in random chance. We've already said that that tweet is simpler than life. And yet the odds of creating that are so small. And I think that that is rather surprising when we think about the probability of life forming. Life is so complex, and random chance just doesn't seem to be able to generate that. So, what am I saying? Should science throw up its hands and say, no, I guess it's not possible. Let's posit a creator. That's not what I'm saying. That's not what science should do. Science studies the physical universe. That's what it should do. Science should never comment on whether there is or isn't a God, because that's outside of the sphere of science. What I am saying is that this is where people like myself, people of faith, have an opportunity to speak into our lives, an opportunity to say, there may be more. Maybe there's more than this physical universe. Maybe this physical universe cannot be explained simply by itself. That's not a scientific argument. It's a philosophical one. And I believe in the postmodern worldview that there is a great deal of room for that kind of thinking. I believe in the postmodern worldview, people recognize that the physical world is only one aspect of who we are. And so I believe that there's a great deal of opportunity for a discussion between science and faith. And I know that discussion hasn't been taking place in a really healthy way very much. I know that many people of faith are trapped in very limited views of science and adversarial views of science, and they cling to very narrow interpretations of ancient texts. And that's really unfortunate, because I believe that right now there's a real good opportunity for a dialogue between science and faith. I am a passionate believer in a creator. And I believe that the creator would really like to say something to the creation. If we look at the texts that exist out there of how the creator has spoken, we can see that there are themes that come out. I've written this blog to try to take a lot of those ancient texts and summarize what those say to this postmodern world. If you want to check out my blog, feel free. The one thing that I've read that God has said is, if you seek me with your whole heart, you will find me. I believe there's a great deal of room in our worldview, in our scientific worldview, for the idea of a creator, for the idea of a God. Thank you.